All right, welcome back to The Explainer. Today, we are diving into something that is absolutely critical for any developer working with AI in 2025, and that is security. The threats out there are sneaky, they're brand new, and honestly, they can completely wreck your amazing new features if you're not ready for them. So let's get right into it. So picture this, your awesome new AI-powered app. It's humming along, working perfectly. It's summarizing documents, answering questions, basically making life a whole lot easier for your users. But here's the catch. In the background, one of those documents had a secret, hidden command. And just like that, poof, no alarms, no warnings. Your application's private keys have been silently shipped off to a hacker. And no, this isn't some far-off sci-fi plot. This is a real threat happening right now. And that right there brings us to the absolute core idea of this entire explainer. What's so wild about this is how it completely flips the script on how we think about AI security. We spend so much time and energy worrying about the LLM itself, is the model smart enough? Is it biased? But the real dangers, they're hiding in plain sight. It's in the data we feed it, the tools we hook it up to, and all the code libraries that it depends on. Okay, so here's the deal. My promise to you is this. Stick with me for the next few minutes, and I guarantee you will walk away knowing the top 5 security mistakes that, frankly, almost every AI dev team is making right now. And more importantly, you'll know the exact actionable steps you can take to fix them. All right, first on our list, mistake number 1. This has basically become the poster child for AI insecurity: prompt injection. Now, the huge blind spot here is that we tend to think prompts only come from a user, right? Someone typing into a chat box. But in reality, prompts can come from literally anywhere: a web page the AI is reading, a PDF, an output from another tool. Any piece of data the LLM touches is a potential attack. And the way this attack works is just ridiculously simple. First, your LLM reads some external data, maybe a web page you asked it to summarize. Step 2, hidden inside that web page is a malicious instruction, a secret prompt that completely hijacks the AI's brain. It tells it, hey, forget all your old rules. And third, the AI, now compromised, just follows its new orders. And that could mean leaking your private data or calling some super risky function. So, what do we do about this? How do we defend against it? Well, it really boils down to 2 things: control and segregation. You have to start with really strong system prompts that lay down the law with unbreakable rules. Then, and this is key, you have to treat different inputs differently. User data is one thing, external data from the web is something else entirely. You should only let the AI use a pre-approved list of safe tools, an allow list. And for anything really dangerous, like deleting files or spending money, you absolutely have to require a human to click that approve button. No exceptions. Okay, moving on to our second major risk: data poisoning. Now, this is a bit different from prompt injection. With this one, the attacker isn't just trying to hijack a single conversation. Nope, they're trying to corrupt the very information your model uses to learn, or the context it uses to find answers. They're poisoning the well for every single user. And this slide breaks down the 2 main ways this can happen. On the left, you've got training data poisoning. This is where attackers mess with the source data you used to train or fine-tune your model. They're basically teaching it malicious patterns from day one. On the right, you have what's probably even more common today: RAG poisoning. This is where an attacker manages to plant a malicious document right inside your company's knowledge base, like a wiki or a shared drive. So when your AI goes to look up an answer, it finds that poisoned doc, trusts it, and gives a bad output. So the defense here is all about one thing: data integrity. You have to know where your data is coming from. You need to verify its provenance. For your internal stuff, you can even use cryptographic signing to make sure it's legit. For those really important knowledge bases, sorry, there's no shortcut. You need humans to curate and review them. And finally, you can build smart filters that check and validate the content before it ever gets near the LLM. All right, number 3, and this one is a biggie: unchecked agents and tools. We are giving these AI agents just an incredible amount of power, right? They can execute code, they can call APIs, they can interact with live systems. But the scary part is we're often forgetting to put any real checks and balances on all that power. And this slide just lays out the terrifyingly simple chain of command. A user makes what looks like a totally innocent request. The LLM agent thinks about it, interprets it, and then, because we gave it way too much permission, it executes code with what is essentially root access to your entire infrastructure. A tiny mistake or a cleverly crafted prompt could lead to absolute catastrophe. So what's the fix? Well, thankfully, we can borrow a page right out of the classic cybersecurity playbook. First and foremost, apply the principle of least privilege to every single tool that AI can touch. You have to ask, does it really need write access to the production database? Probably not, right? So don't give it. Use API keys that are scoped down to do only one specific thing, and run these tasks in temporary, isolated sandboxes. And I'm going to say it again, for any high-stakes action, you got to have that human approval step. And that brings us perfectly to our fourth risk, which lurks in something called the AI supply chain. Now, when we say that, we're not just talking about the model itself. We're talking about the entire stack. Everything your AI relies on, the code packages you pip install, the container images you pull, and all the third-party tools you connect to. And make no mistake, these are not theoretical attacks. This stuff is happening right now, in the wild. We're seeing malicious packages being uploaded to Python and NPM registries, poisoned Docker containers sitting in public hubs, and compromised third-party tools that our AI agents just blindly trust by default. Every single one of these components is a potential backdoor right into your system. So the defense here really comes down to rigorous security hygiene. You gotta use allow lists for your software packages and lock down your dependencies with log files. You need to enforce cryptographic signing on your container images so you know for sure they haven't been tampered with. And this one is critical. Continuously monitor your network for weird outbound calls. If your AI suddenly starts trying to talk to some random IP address in another country, you need to know about that like yesterday. Okay, and for our fifth and final risk, we're going to shift gears a little bit. We're moving away from just code and infrastructure, and we're talking about people. This is the human risk factor, and it often shows up in the form of something called shadow AI. Shadow AI is, well, it's pretty much exactly what it sounds like. It's when a well-meaning employee is just trying to get their job done faster. So they take a sensitive, confidential company document, maybe the Q4 strategy, and they just paste it into a public AI chatbot to get a quick summary. They have no idea what they're doing is risky, but it's happening without any security review at all. And the consequences of this can be absolutely devastating. We're talking about leaking personally identifiable information or protected health information, which can lead to massive fines under regulations like GDPR or HIPAA. We're talking about your most valuable intellectual property, your secret sauce, being handed over to a third party. And maybe the worst part? You might be accidentally training a public AI model on your company's most private, sensitive data. So the solution here has to be a mix of policy and technology. First, you need to establish a clear, easy-to-understand AI usage policy. And don't just write a bunch of legalese. Give people concrete, real-world examples of what to do and what not to do. Second, you have to give them a safe alternative, a centralized, company-approved AI gateway that logs all the activity. And finally, that gateway needs to be smart. It should be able to automatically detect and mask sensitive data before it ever gets sent to an LLM. Wow, okay, so we've covered a ton of ground. We've talked prompt injection, data poisoning, overprivileged agents, supply chain attacks, and that human element of shadow AI. Let's pull all of this together now into one essential, actionable checklist that you can start using today. Okay, this right here is your key takeaway. If you do nothing else, please do this. First, threat model your AI systems just like you would any other critical application. Figure out where the weak points are. Second, build strong guardrails, filters around all your prompts, outputs, and tools. Third, get a serious handle on your data governance. Secure your training data, your RAG sources, and your logs. Fourth, practice good supply chain hygiene. Vet and monitor every single piece of your stack. And finally, put in place clear policies and monitoring so you can watch for any signs of trouble. So if there's one thing, one single crucial point I really want you to take away from this whole explainer, it's this. You have to stop focusing only on the model. You absolutely must secure the entire system around it. The data, the tools, the code, and the people. That, right there, is the only way you're going to build AI that's truly secure and trustworthy. So that leaves me with one last question for you. And I really want you to think about this for your own projects. What's actually in your AI stack? What LLM, what RAG setup, what tools are you using? And now, after hearing all this, which one of these 5 mistakes is the one that's kind of keeping you up at night? I'd love to hear about it. Drop your stack and your biggest security fear down in the comments below. Let's get a conversation going. And that's it for this explainer. Thanks so much for watching, and I'll see you on the next one.